Let's start with question number 3. Solve the inequality, okay, and do you see its absolute values? Okay, but again, I first want to take you back to the textbook. And I'm taking you to chapter 8, algebra. And the page I'm taking you to, let's just go. We're just going to refresh your memory. It's page 377 in the AS-Level Mathematics textbook, y equals mx plus c. Okay, now let's look at this one. And this is more or less the same. Do you see the two absolute values and the inequality sign? Now, there's two methods. Now, I'm going to do just actually method 1 because I think it's the easiest method. But I want to show you that you can also use another method. So, using algebra. Now, to get rid of that absolute value bars, I square both. Okay. So, as soon as I square both, then I got rid of that. Then I simplify that, Okay, remember it's an inequality. Then I take everything to one side if it's a quadratic inequality. Okay, now I'm just going to bring this in. I'm going to solve that now. Now, how do I solve that? I solve it with a sketch. So I first make it an equation. Okay, I just copy it there, y equals. Now, due to the fact that there is in front of the x squared a negative, I know that it's not a smiley face. The graph will look like this. Then I put the y equals 0. This is what I do. I factorize it and I get that two values where it cuts the x-axis. Now I go back to the inequality. I didn't show you here, but I'll show you now. I say, because the inequality say smaller. Now, I showed you. It's just not so clear here. It's under the x-axis. If it was bigger, it's on top. And then I describe. Now, if it's two separate parts, then I will say, okay, and now I'm going to, okay. So then I will say it's x smaller than 1 and x bigger than 7. Are you with me? It's not, because it's two separate parts. It's not a combined part. Okay. Now, remember to check your answers in the absolute value equations. So basically, I can just take that and I just substitute it in there, in both. Okay. So let's just substitute it in that thing. So I'm going to say 1 and 2, let's just see. 1, I substitute 1 in and I see it's correct. And I substitute 7 in and I see it's correct. Okay, so that is very important that you check. Now, the other method I just want to show, and you can really on your own try to do it in the question paper also. It's the method of using a graph. So basically, I will go and I will break this up into two graphs. So I break it up in this graph and this graph. And then I sketch the graph. So you have to go back and see it. Remember how you sketch the graph. So if I'm just going to sketch the one and sketch the other one. Okay. So to get the turning point, I put this equal to 0. I would actually love to tell you where in the textbook you can sketch it. So if you want to revise how to sketch it, you can look in the textbook on page 373. I'm just going to write it here. Page 373 is how to sketch it. But it's actually all that you do is if you want to see where it cuts the x-axis, you make y0. If you want to see where it cuts the y-axis, you make x0. If you want to find the vertex, okay, you take the absolute value part and you put it equal to 0. And that answer you put in the original equation to find your y coordinate of your point. Okay, but as I said, I'm not going to focus on that. But after you make the sketches, you are just going to look at the statement. Now, if you look at the original statement, and I want to take you back here, it's where this one, the x plus 2, is smaller. So where is the x plus 2? Do you see there is the x plus 2? So now remember, the one that's smaller is the one that's under. Okay. So can you see there it's on top? Okay. But if you see there it's under and there it's under. So then where this one is under the other one, It's from there on, and that's I showed you with the arrow, because there's not an equal sign, that's why it's opposite circles, and from there on. So from the sketch, you can basically, from the sketch, you exactly get that, and then you can also describe that. Okay, so that's how you sketch. But let's go back to the question. So, to get rid of this absolute value bars, we're going to square every side. And just make sure that you square it correctly. You can either write it out and then do long multiplication, or what I do is I square the first term, so it's 9x squared. I multiply this two with each other, so I get 9 times 2, 9x times 2, so I get plus 18x. And then 3 times 3, that is 9. So just make sure that you don't miss this middle term. Otherwise, as I said to you, go and then just write it out here. 3x plus 3, 3x plus 3, and do it like you did it in grade 9. Okay, keep your sign. We do the same. So this is going to be x squared. This is 5x times 2, so it's 10x. 5 times 5 is 25. Now, as soon as I see inequality, quadratic, I take everything to one side. Now, sometimes you can put the same terms, but I prefer rewrite this one. I don't know. Sometimes if I put the same terms, I make mistakes. And then I rewrite this whole one just with negative signs, or changing the sign. Okay, then this is my like, and I just underline it. So I get 8x squared. This is 18 minus 10, so this is 8x. And this is 9 minus 25, so it's negative 16, and it's smaller than 0. Now, simplify. You can see 8 can divide into all, so it's always better to work in the simplest form. Okay, now what I do, and as I said, you can use a pencil now to help you. So I'm just going to sketch the graph of y is equal to x squared plus x minus 2. Okay, so I first say this is positive, so I know already that it's going to be a smiley face. Now I put in place, to see where it cuts the x-axis, I put a 0 in the place of y. Please remember not to write in the examination line. You can write it on the side. Okay, or on that side, or on your extra paper, doesn't matter. But not your extra paper, the extra paper that's in the question paper. And that is the additional, and if you want, it must be the additional is on page 16. If you want the examiners to see something, remember to mark anything that you write, say number 3 or something like that. But there's enough space. So, okay, I'm just going to do this. So I'm going to say this is going to be 2 and 1 and 1 and 1. This is negative, so it's going to subtract. So 2 minus 1 is 1. And the biggest over cross product, get this sign. So it's plus, and then it's different signs, minus x. If I put this equals 0, because all I'm trying to do is to get that x values, where it cuts the x-axis. So it's negative 2, or x is equal to 1. Okay, now I'm going to make my sketch. So as soon as I make my sketch, okay, remember it's a smiley face. Okay, my pen is not correct. Let's just get it correct. Okay, so this is negative 2 and this is 1. But now I look at that sign. What is that? Smaller. So smaller, and I'm going to show you by this. So smaller will be under the x-axis. Okay, so the part under. If it's bigger, it's on top, the part on top, but that's under. Now, due to the fact that you see it's one region, it's not two separate regions, it's very, very, very important that you put it x, and then if it's 1, it's almost like you make this little open to that side, and then you fill in. So it's read it from the middle. So x is bigger, okay, So bigger, so it's to this side. It's almost like we are going to explain or show this. So x is bigger than -2, and you can actually see it's almost, and smaller than 1. It's almost like you put the x there and you just do this. Okay, and there's the 1. So x is bigger than -2 and smaller than 1. I'm going to say this again. You can make a sketch of this, and you can make a sketch of this, and then say where this one is smaller than this, that. But according to me, this was the fastest, the easiest, and I don't even want to highlight the other method. Okay, where will you get your marks? You will get your marks, and I forgot to mark it here in this question. So I just have to see where you will get your marks. And it's just going to be, if you did the quadratic, like there, you will get a mark. If you come to this 8x squared, or is it 4 marks? Okay, so this question is actually quite a lot. So if you come to this square, and if you then get your the factorizing part, so they will even look here, okay, to see. So, and then your final answer. Okay, so to obtain the 2 critical values. So that is where you will get your answers, and that is how you will get your 4 marks. Actually, very nice and easy. Let's start with question number 4. A supermarket campaigns to reduce the use of plastic bags. The number of bags N used in a particular week is given by the formula there. Okay. So N equals 5,000 E to the power, I'm just going to make it bigger, let you see better, to the power -0.02 T, where T is the number of weeks since the campaign began. Sketch the graph of N against T. Okay, so just a few basic things. Don't forget, this is actually Y, and this is representing X, okay, which is now N and T. Also, don't forget, T represents the weeks. So if T in the beginning, so if you want to see how many bags there was in the beginning, you can basically say, okay, N equals 5,000, and then E minus 0.02, and then if you put a 0 there, then you get 5,000 E to the power of 0, which is 1, which is 5,000. That was the amount of bags in the beginning. Okay. Now, if you must sketch, I'm first going to take you back to the textbook, and then I want to show you the basic figures, and then I'll come back to this statement because this is already going to help me a little bit. Okay, let's go to the textbook. Okay, now in the textbook, it's very important, and they are saying it in the general report. They say candidates must not be encouraged to use tables and plotting points to enable them to draw basic graphs. The basic shapes of the graphs as well as their transformations must be taught. Okay, so this is very important. This is, if we go back, we will see it's an exponential graph. There's not a log or a lin in, so it's an exponential. And this is the graphs of exponential and logarithmic functions. So let me just refresh you a little bit on that. Okay, and because this is more or less, I'll take you to the log one also. So basically, this is the shapes that so if it's e to the power of x, doesn't matter, if it's positive, it will go like this. And as soon as they make it negative, it will go like this. How will you find that value of 1? Just like we always do. If you want to see where it cuts or intersect the y-axis, what do? You make x 0. So you make x 0. So if, say for example, that one, say you have now, okay, it's ux, y, and you make it 0, then it's e to the power 0, it's 1. And where does it cut there? At 1. Okay, so just remember, as soon as this was going up, and this one will just go down. Because if I'm taking you back, you must take note that they were just indicating this part. So, but it will still be down. It will not be this shape. Do you see? It's a reflection in the y-axis. So this is the positive and this is the negative. Okay, if I go up, I just want to show you. Okay, this is just, I want to show you another page. Now, this one was not asked, but I just want to show you, especially for this examination, and this is referring to basic shapes. Now, if you okay, you remember now the previous one, okay. So, but if you look at this one, this is the basic log or ln one. And again, if this was the positive, and if it comes to the negative, then it was a reflection in the x-axis. So at least just know your basic graphs. That is really going to help you a lot. And this was found on page 418. And I don't know if I showed you the previous one. But this one was found on page, okay, I just want to move it up a little bit. And this one, the one I'm going to, it was on page 415 in the AS-Level Mathematics textbook, y equals mx+ c. Okay, but I'm going to work more or less, this one must jump. It's a decreasing function, so keep it in mind. Let's go back to the question paper. Okay, now, as I said to you, it's just a little bit more complicated than the basic one, but still, do you see it's negative to the power of x? Okay, so this would be the positive and this would have been the negative. Okay, but if I want to see where it cuts the n-axis or the y-axis, I make x, which was in this case t, 0. So it's at 500. I still want you, if you do it, still do it a little bit on scale, you know. So although I don't think it's going to have quite an influence here because you don't have any other point, but I was just deciding, okay, I'm just going to make it 5. So, but as I said, I don't think actually that it's going to have a difference here. So in this case, it's 1,000, 2, 3, 4. Okay, let's make that 5,000. That is very important. And then remember, it's coming like that, but they want just in this quadrant. So they just want this part. Okay, something like that. That's what they want. Okay, so very important is the shape. And that you indicate that my point is now not, but that is 500. Or you can say 0, 5, not 500, 5,000. Okay, and what is my graph's name? Always label your graphs and make it a bit smaller that you can see better. So remember, instead of the y, it's just n is equal to 5,000 e to the power negative 0.0, and that was 0.02t. Okay. So sketch the graph n against t. So please, a table, it would have been it's a basic, it's an exponential graph. Now, it's just the negative, so the positive would have go like this, the negative would have go, but there it cuts. Now they go on in this question. They say, calculate the number of full weeks before the number of bags used is halved. Okay, now if you do this one, now remember that it was starting by saying n is equal to 5,000 e to the power negative 0.02t. Now half. Okay, so let's work out when it will be half. Exactly, on the dot. So if it's 5,000, then half will be 2,500. So let's put in. Okay, I'm going to say when the value of n is 2,500. I'm looking for that. Okay, so when n, so calculate the number of full weeks before the number is halved. So there I put, that is my normal formula. Okay, now I'm just going to simplify. This is an exponential. I divide by 5,000. I divide by 5,000. Now I get 0.5. I think the decimal works better here because it's exact. Okay, now remember, as soon as you see E, you don't go to log, you go to ln. Okay, so it's almost like taking from exponential form to logarithmic form. So this is going to be ln. Okay, and now what do? It's always like you swap this two. So it's going to be, there is now the ln, and then it's 0.5 equals negative 0.02t. Okay, and now you can basically just divide by negative 0.02, divide by negative 0.02. And now you can just take your calculator and you can just press on your calculator. So press ln 0.5 divide negative 0.02 equals, and I'm getting, let me just write it down. I'm getting, so therefore, t equals 34.7. Okay, but now if you look in this question, so by 34, but they were actually nice. They took both answers correct. They accept 35 also, because exactly then it will calculate the number of full weeks before the number of bags used is halved. So after 34 weeks, it will be, in that next week, it will halve. So you could have said, but full weeks, you cannot stop with this answer. They say full weeks. So therefore, 34 full weeks. But as I said, they also accept 35 weeks as an answer that I see in the memo. Okay, and where will you get? Okay, let me just go back for this one. You will get for the shape. They will look at your shape. That is for the shape. And then where it cuts the n-axis, y-axis. And then for this one, you will get where you realize this is half, so that where you put in the 2500, and then when you came to this, and then when you, full weeks, when you either this one or this one, then you would have got your other mark.